Today, I want to talk about the truth table. The truth table is an important tool for understanding logical operations. Logical operations are so crucial to information systems development. It's used in creating circuit gates, used in developing circuit boards, is used in several parts of programming, is used particularly to take decisions. So it's vital and important that we understand and learn how to use the truth table so that we at least get some understanding of the nuances of logical issues. We can decide. We can understand logical flow. We can deal with decision making. So the truth table is very, very important. I have often found myself referring students to go and look at the truth table, especially to understand comparison operation and understand bitwise operator. So in this presentation, I want to talk about the truth table. I will be looking at logical operations and or and not, and examine how to construct the truth table. Some unary logical operations like logically true, logical false, and identity. I will talk about and or and not in the truth table. We'll also look at the expanded truth table, talking about operators like XOR, NAND, and NOR. Then the use of the binary truth table, which is essentially converting true and false to 0 and 1, so that decisions could be taken and bitwise related operations could be done. So the truth table is actually a mathematical table that is used in logic and often used in Boolean algebra, Boolean functions, operational calculus, and it involves dealing with a combination of values as well as their result. What the truth table does is actually to say, if you are given two values, usually it's called Q and R, what would the result be? So you have a table in which you have one column for Q, and then you have true and false, and then another column for R, and then you have true and false again, and then another column for result. That is just it. So the whole essence is that, so if you are given a true value and then another true value, and the operator is AND, then the result will be true. Or if we are given a false value and the second one is a true value, then for an AND operation, the result will be false. So it's essentially like that. And so why do we need the truth table? Well, it's used for understanding comparison operators and operations. It lets us deal effectively with decision making. It may help us understand logical and fallacious statements. It makes us to understand how logical electronic gates fired, and it's also useful in understanding bitwise operation in programming. Constructing the truth table, like I explained earlier, is just a matter of having mostly three columns. The first column, you have the first operator and the first operand. In the second column, you have the second operand, and then you have the result of the two operations. Usually, you will find the two variables and then the operand, which is either and or not, as required. So there are some unary operations that are useful and important to know. The first one is the logical true. So in the logical true operation, what we are saying is that the operation will always return true. So irrespective of what the input is, the result will always be true. So it's like you have a light that has a switch, but the switch will not work because the light is always on. So whether you put the switch on or you put the switch off, the light will always be on. Or you have a light that has the bulb has blown, and then you are trying to put it on or put it off. Irrespective of whatever you do, the result will be either true or false. So the logical true operator is an operator where whether the input is true or the input is false, the result is always true, and that is represented by this table. So the input is true, the result is the input is true, the result is true. The input is false, the result is still true. That is a logical true operator. And then another one is the logical false. The logical false operator, that means whatever you do, the result is always false. So the input is of P, and then the input is true, but the result is false. The input is false, but the result is also still false. That is the logical false. So we have the logical true, in which the operation will always return a particular value. So true is always true. And then the logical false is an operation in which the result will always be false. And then, of course, we have the logical negation. The logical negation is one in which whatever the value is, the result is always the opposite. So if the value is true, then the result is false. If the value is false, then the result is true. That is what the logical negation is. The logical identity is actually saying that the result is whatever the input is whatever the result will be. So if the result is true, if the input is true, then the result will be true. If the input is false, then the result will be false. That is known as logical identity. So these are four unary operators that we have looked at. Unary logical operator. The first one is logical true, where the operation is always true. The second one is logical false, where the result is always false. The third one is logical negation, where whatever is given, the result is the opposite. And the fourth is the logical identity, where whatever is the result is, whatever is the input is the same thing as the result. So there are situations where you meet this type of operators logically, and then you are able to just deal with them, and you should be able to understand and deal with them after this lesson. The next one we really want to look at again are the most common ones, the three most common logical operators. The first one is logical AND. These are binary operators. They take two operands. The first one is logical AND. Okay, the two of them take logical. They take two operand, but the other one, which is the logical NOT, actually takes one operand. So the logical operator, logical AND, is also called logical conjunction. So for logical AND, the thing to know about logical AND is that when you have the AND operator, the only time that the AND operator is true is when the two inputs are true. At every other time, an AND operator is always false. That's the thing you need to know about logical conjunction. So let's take this logical AND, and then we'll look at it. Then the second one is logical. So the second one is logical disjunction or logical OR. The thing to know about that is the only time that the logical OR is false is when the two inputs are false. At every other time, the logical OR is always true. So in a way, the logical AND and logical OR appears to be opposite flip of the same coin. We'll take a more detailed look at them in a few minutes. The logical NOT. For the logical NOT is like we talked about logical negation in a few seconds ago. When the input is true, the output is false for logical NOT. So that's logical negation. What we are saying is when the input P is true, the result not P is false. When the input P is true, the result is false. When the input is false, the result is true. That is if the value is true, then the opposite of the value is false. If the value is false, the opposite of it is also false. The same thing for Q. So that is what logical NOT is all about. Let's take a brief look at it. Usually, when you look at logical AND, it is written in a particular way. It's written like P and Q, and they're written like this, or written with ampersand, or written with a dot. But irrespective of how it is written, the whole idea is whenever you see AND, the thing to know about AND is that the only time that the result of any AND operation is true is when the two values are true. Otherwise, the result is false. That is the thing to know about the logical AND operator. When the two values are true, then the result is true. Otherwise, the result is false. So if P is true and Q is false, the AND P and Q is false. If P is false and Q is true, then P and Q is false. If P is false and Q is false, then the result, which is P and Q, is also false. So the only time that this operation is true is when the two inputs are true. That's the thing to know about it and to always remember about it. This also will work when we convert this to binary. So the binary hand expects you to have P is 1, then Q is 1, then the result is 1. When P is 0 and Q is 0, then the result is 0. When P is 0 and Q is 1, then the result is 0. And when P is 0 and Q is 0, then the result is still 0. So the only time when the result of an AND operation is 1 is when both P is 1 and Q is 1. I hope from now on you understand what logical AND does. Let's move to logical OR. So for logical OR is written usually in this way. So at times it's written with P with the U operation, or APQ, or P with the double perpendicular line, or P plus Q. So here, when the only time that the logical OR is false is when the two inputs are false. So if P is true and Q is true, then the result of P or Q is actually true. When P is true and Q is false, the result is still of P or Q is still true. When P is false and Q is true, the result is still true. The only time that P or Q is false is when both P and Q are false. So we move forward to the logical NOT. We have explained that that's usually written with, and then in some programming languages, we have an exclamation sign in front. But what we are saying is that whatever value is the input, the result of it is the opposite. Whatever value is the input, the result is the opposite. Whatever value, if P is true, then the result of not P is false. If P is true, the result of not P is false. If P is false, the result of not, if P is false, the result of not P is true. If P is false, the result of not P is false. If Q is true, the result of not Q is false. If Q is false, the result of not Q is true. If Q is true, the result of not Q is false. If Q is false, the result of not Q is true. So that is the way logical operation works. So if you convert that to bitwise operation, if you have 1 here, then the result of not 1 is 0. If you have 1 here, the result of not 1 is 0. If you have 0 here, the result of not 0 is 1. If you have 0 here, the result of not 0 is 1. It's the same thing like that. So 1, if you apply the complement or negation to it, it becomes 0. 0 becomes 1. So is that that is the way it is. So, but there are a number of other operations that are similar to those. Some of it is the NAND. One of it is the NAND and the XOR. The NAND operator, for instance, is actually like not AND. So what that does is it looks at the result of, so if you look at the NAND operator here, so true and true is false. True and false is true. False and true is true. False and false is true. So the NAND operator will actually look like an OR. We also almost look like the result of an OR function, the same. And there's another one called the XOR, or called exclusive OR. The exclusive OR will not be true when the two results are true. It will only be true when only one of the results is true. So, for instance, for the exclusive OR, which is XOR, true and true is false, and then true and false is true, and then false and true is true, and then false and false is true. False and false is false. So the only time that exclusive OR will be true will be when true and not true are XORed together. That's what the XOR operation is all about. So all of these operators are logical operators, and they are available to help us in logic. And converting it to logical, I've explained how to convert this to the logical table. So you can take those tables, and instead of wherever they're supposed to be true, if you put 1 there, and wherever it's supposed to be false, if you put 0 there, you can take the truth table and easily convert it to binary truth table, so that 1 and 1 is 1, 1 and 0 is 0, 1 or 1 is 1, 1 or 0 is 1, not 0 is 1, not 1 is 0. So is that simple. So that is the truth table in a nutshell. Please let me know if you have any questions with regard to this. But as we have discussed, it is applied in binary operation and in bitwise operations, as we have seen, including things like shifting the bit right or left, moving those zeros, and then actually deciding on certain bits, depending on whether you are holding it or you are handing it. So I hope this video is helpful. Give feedback, subscribe to more video from this channel. Thank you very much.